What's up, guys? We're back. Another episode today. I think episode 70. Wow. 70. Let's check out our Pokemon of the day. We got a Weeping Bell. Weeping Bell Pokemon. Let's check out the sound. Got a little cry here. Does that sound? Check it one more time. Does that sound? I'm actually curious. What is the latest Pokemon game? I haven't played Pokemon in forever, bro. Pokemon Smile. They stopped making the games? Scarlet, the franchise began its 9th and current generation Pokemon Scarlet and Violet. What year was this? 2022. Wow. That's cool. Interesting. I'd have to take a look. But yeah, let's take a look at our problem of the day. It is cold again in my apartment. Take a look at this easy problem. Divide array into equal pairs. You're given an integer array consisting of 2 times n integers. Okay. You divide nums into n pairs such that each element belongs to exactly one pair. The elements present in a pair are equal. Return true if the nums can be divided into n pairs, otherwise return false. There are 6 elements in nums, so they can be divided into 6 out of 2, 3 pairs. If nums is divided into 3 pairs, 2, 2, 3, 3, 2, 2, it will satisfy all the conditions. The elements present in a pair are equal. Each element belongs to exactly one pair. Okay, so these are our conditions. You're given an integer array consisting of 2 times n nums. 2 times n integers. Okay. Hash table bit manipulation counting. Okay. I'm gonna just kind of go off this array such that follow these 2 conditions. Each element belongs to exactly one pair. So let's create our little hash map here. We can do let's do the normal way, right? So we create a dictionary because we can easily do like MindDic is equal to counter of like nums. That's easy. I kind of want to do the actual way without any inbuilt thing. So we create our hash map and populate it. Right. Come over here for I in range like nums. If if nums I in my dictionary, then we do my dictionary nums I plus equal to 1, else my dictionary nums I is equal to 1. Right, so we populate our array. Let's just take a look really quick. Print our dictionary, right? Take a look really quick. Okay, populated our dictionary. So obviously we want to take the length, right? We want to take the length of our nums, so length is equal to the length of nums, right? I guess we can switch this to length, because why not? Alright, switch this to length. And we check, well, hash map here. How can we manipulate these values? Length is equal to length over 2, right? We need to find how many pairs, right? So we need 3 pairs, right? If I sent to, let's just put this back to the length of nums and get rid of this. We don't really need this actually. We just do the length of nums here. With nums, we can just change this to length. Okay, for for key value in my dictionary dot items, we want to check, well, if value %2 is equal to 0. So if it's even, right, we want to check, well, value in my dictionary dot items. Anyway, okay, let's do if value is greater than or equal to 2, then value minus or equal to 2 let's do a while loop here. While value is greater than or equal to 2, then we want to decrease our value and then decrease our length by 1. All right. Do we need the key? I mean, probably not, but okay, we return true if length is equal to 0, else false. There we go. That worked. Hopefully. Yay. Nice. What's the fastest solution? For okay, they do a counter. Okay, for counter values if return true. Okay. Mine was probably way too much code to. Nice. Well, it was a nice problem. Nice problem to begin with. I mean, my solution is probably way too long, but could have been way shorter. But that's okay. We solved it. Why is this not pushing? Leetcode, why are you not working, bro? No contributions March 17th, dude. Why are you not working, bruh? Bruh. Bruh, 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 bruh. I don't like this, bro. Let's refresh the page, man. Maybe we just gotta refresh, bro. We resubmit. Pushes. We submit. There we go. This should be an update here now. Just now. Wow, look at all these problems we solved, man. Should be green now. There we go. Okay. Yeah, last year, this is my spring break week. Alright. Okay. Let's take a look at something else. Let's take a look at our powerful study program. Alright, let's take a look at a binary search problem. Check completeness of binary tree. Kth smallest element. Convert sorted array to binary tree. Let's take a look at this one. Ooh. Given an integer array nums, where the elements are sorted in ascending order, convert it to a height balanced binary tree. We go left, left. Okay. Then we got to think about how we can move this array into a binary tree. Do we sort the array or is it already sorted? It looks like it's right. Nope. Maybe we sort it. No. Do we sort it? Maybe it is already sorted. What's the best way to go about this one? You take the mid value. I'll be back. I gotta blow my nose. 1 second. Okay, we're back. Feels so much better now. Okay, so we're gonna need like looks like a recursive solution. Kind of realize you kind of need to start from there. Give me hints for recursive solution. Way left to go. Oh. Um, okay. FBST, you want to pass in the array, right? Call out BST function array. I guess we can return that. So we need to find our midpoint, right? So mid is equal to we have to pass in our left and right as well. Our left is equal to 0, our right is equal to array, sorry, the length of the array minus 1. We find our midpoint, and our midpoint is mid is equal to low plus high over 2. We don't want to pass in our array. Actually, that's stupid. Why would we pass in our array? Turn BST. Can we find our midpoint, right? Then what do we want to do? We want to create a tree node, right? With that node, create a tree node. To do that, we'd have to do, well, node is equal to tree node, and then we reference our array mid. Okay, and then we recursively call left and right. Node.left is equal to the tree node. Then we call our function. No, node.left is just BST gonna do the left of it. So if we go left, mid -1. Sorry, no, it would be low, mid -1. No dot right would be BST mid +1 high. Then I think we just return our node. I think. I just switch this to nums mid. Low is not defined. Let's just do start end, bro. Maximum recursion depth exceeded. Maybe we need to end the recursion. Okay, well if start is greater than end, then we just want to return none. There we go. Boom. Oh man, it's so cold in here, bro. Okay, let's do another tree problem. Have we done this one? Bro, what an interesting problem this is. Damn. I'm trying to think. Would I recursively could I run both DFS and BFS? Is that crazy? I don't know. I'm thinking I run DFS on the right part of the subtree and just move right until it's null, right? And then we run BFS and only return the first value if there's one value in the floor. That's what I'm thinking. We append them all to... Okay, let's do that. So, how do we begin this? Let's do def right DFS. Alright, we just want to pass in our node. Pretty much we just want to call our function def right. Sorry, actually, right DFS. We pass in our node, right? We got to create a res array, right? We loop through and we do, well, if not node, we just return, right? It's our base case. We don't really need to return anything down here because we're not actually returning anything. We're just adding it to an array. So then we do, well, node.write is equal to write DFS node, right? And we just want to append each value, append each val. Yeah, node dot, res.append node.val. Friend keeps texting me. Okay, let's print our res array there. Let's see what we're getting here. Node is not defined. We want to put in our root, and we want to append right. Maximum recursion depth exceeded. Do we have to return none here? Maximum recursion depth exceeded. Why are we getting that? No dot right. Oh my god, yeah, we're not doing dot right. We're just passing in our node. Okay. 134. Okay, good, right? So run right DFS. Okay. And then we want to run our BFS. Run BFS, right? So we do collections, import, DQ. Shit. DQ in Python from collections. Man, from collection import DQ. We run our BFS here. So then we create Q is equal to root. Q is equal to DQ root. Right? Then we do while Q. We take our length is equal to the length of our Q, right? Then we do for I. Oh, we don't even need I for in range length, right? And then we do well if length is, oh, well, we'd have to skip our root node. So root node is going to be a length 1. The BFS won't work because our root node is 1. We're gonna have to make some sort of like depth variable or something. Depth is equal to 1. Depth plus equal to 1, right? Well, if length is less than or equal to, sorry, if length is greater than or equal to 2 and depth is greater than or equal to 2, we just want to break. Sorry, would we just break? Otherwise, we would just want to do add our val to our array, right? So we would do nums.append no dot val. Oh shit. Node is equal to q dot pop left. Right, that we add our value to our array. Oh, but that won't work because we won't be able to add all the children. Well, I guess. Well, I guess it doesn't really matter though, because if the length is 1, right, then you're only gonna have one child underneath it. So I guess it'll still work. I think, maybe, I don't know. We append our val, and then we, if no dot left, then q is it append? No dot left, no dot right, q dot append, no dot right. Is it append or is it? I don't know. I don't remember. Append. Okay. Q dot append right. Because if you think about it, this isn't gonna work. We have to restructure this BFS approach. Obviously, we don't want to add the root, so we need a depth counter, right? I think we need other test cases though. That's the issue. Like, let's return our res. TrueNode object is not iterable. I think we gotta do this here. Nums is not defined. Sorry. Res. There's no attribute val. $199 binary tree right side view. What do you think about my DFS and BFS approach? Oh. Okay, so maybe you only need to do one of the two, not both. Okay. Let's get rid of this BFS. Interesting. We keep a depth here. I understand. Right, so we have a 0 here. So I think we need to add no dot left here. Right key first, no dot left. And then we add our depth. That's so smart. We compare it to the actual array. I would not have thought about that. It's a really, really smart way to do it. If the length of res is equal to the depth, then res.append no dot val. That's so smart, bro. Oh my gosh, I would have never thought about that. If the length of res is equal to the depth. Okay, let's think about this. Let's go through our case 1, right? Sorry, no, case 2 is a better one. We have our root node, right? And we append. Well, the length of this is 0, so we append our root node, right? Then we go no dot left, no dot right. We append no dot right first because we want to traverse the right subtree first, right? So we append no dot right. We see that the length of that is equal to what the depth is, so we append that, right? And then we append its children. We realize its children are none, so they return none. So then it backtracks to here, right? Yeah, and then it backtracks back to 1, and then we go left, right? We realize, well, since the depth is equal to 2 and it's not equal, we don't append this one, we go here, right? So but then we go no dot right. We realize this is none, we backtrack, we come here, no dot left. We realize we haven't appended this level yet, we append this one, and then we go no dot right. We realize it's none, we backtrack, we go here and we append 5. That is so smart, bro. I would have never really thought about that. So impressive, like insane. I'm so itchy. Okay. Yeah, we're gonna do a BFS approach now. I just want to do it. I think the BFS approach is a little bit easier to think about, to be completely honest. I just want to do it just so, like, you know, we get that refresher. Q is equal to dq, right? We pass in our root, right? Do while q, we grab our length. Our length is equal to the length of our q, right? Then we do a for loop, find range length, We want to pop here, so we do node is equal to q dot pop left, right? And then we check, well, we only want to append the rightmost value. And if we're going by level, we need to think about, well, what is the rightmost value? So actually we're going to need I in this case, actually. So if our I is equal to the length minus 1, then we want to append this one to our res array, right? And then we just do if no dot left, we do q dot append no dot left, and then out here we do if not no dot right, so we do q dot append no dot right, and then we want to just return our res. I think this should work. Ooh, res is not defined. Oops. Res is equal to this. We run this code. Oh, we have no attribute val. Okay, we might need a little if not root, we just return an empty array. There we go. We got a little BFS approach here. Let's post our solution, because why not? Easy interview BFS approach. I think our space would be O of n, right? I think. Yeah, O of n. Okay. O of n. We haven't done this in a little while. O of n. Intuition. Think about returning rightmost value traversing by level using BFS. Our approach is a simple iterative BFS approach using a queue. Sick. Please upvote. Level order traversal 102. Gotta go whole hard this time. Gotta go whole hard. Gotta go whole hard this time. Gotta go whole hard. I've done this one. Gotta go whole hard this time. Gotta go whole hard. When did I do this one? Submissions. Oh, did it like nearly a month ago. Given the root of binary tree, return the level order traversal of its nodes, i.e. from left to right. I.e. from left to right, level by level. So it's BFS. Yeah. All Q. Okay, well this is not necessary, this part here. We can just do res and we can just append the node at each level, right? Oh wait, no. Oh, okay, that's why. We're appending all the nodes at each level. Yeah. Interesting. Cool, bro. Cool beans, bro. Cool beans. Let's get to that 40 problems here. Lowest common ancestor, maximum difference between node and ancestor. Maximum level sum of binary tree. This is so easy. Right, this problem's so easy. Given the root of binary tree, the level of its root is 1, the level of its children is 2, and its root is 1, the level of its children is 2, and so on. Return the smallest level x such that the sum of all the values of nodes of level x is maximal. Level 1, level 2, so we return the level with the maximum sum, which is level 2, 7. Okay, well, see how this is a BFS approach, like, we can instantly tell. Right. So we do, well, create our queue. Our queue is equal to, we pass in our roots. Then we do, well, I don't know. I don't know if my mic is buzzing. I feel like my mic is buzzing. I'm gonna. I gotta fix my mic really quick. Hope that's better. Hello? Hello? Okay. Alright. Okay. Let's take a look at this. So we got our root here. Then we do a simple we need to create a res array, right? To store all that stuff. A little res. So we do, well, while we have something in our queue, we loop through for our length in queue. Oh, sorry, no, let's just do our normal length, right? Wanna just length is equal to the length of our queue, right? We loop through, then we do node is equal to queue.pop left, right? So we pop. Then what do we want to do? Let's do our, like, sum is equal to 0, right? So it resets each time. And we do, well, node sum, let's add up sum. So that we do sum plus equal to, oh my god, node dot val, right? Sum plus equal to node dot val. Let's change this so it's cur sum. Do cur sum plus equal to node dot val. We add up our sum. Then we do, well, node dot left. Node dot left. We want to queue dot append node dot left. If node dot right, we want to do queue dot append node dot right. Right. And then we just want to, well, return our res, right? Oh, sorry. We want to return the max of our res. Because we want to return the max value. I think we're going to need our I here as well, actually, because we're not going to need to do, well, if I is equal to the length minus 1, then we want to append to our res, right? So res dot append cur_sum. We will return our max value. I think this should work. There's no attribute pop left. If not root, we just want to return 0, right? Object has no attribute pop left. Why do we have no attribute pop left? Why are we getting this error, bro? Why are we getting a attribute error? List object has no attribute pop left. Oh, this queue is defined as a list instead of a DQ. Oh shit. Oh my gosh, whoops. My bad, dude. There we go. Output. Oh, we want to return the level, not the sum. Okay. Oh, shit. Okay. We want to return the level. Okay. To make another variable with our level is equal to 1. Then as we loop through here, we're going to have to initialize it outside, right? And every time it comes here, we do level plus equal to 1. And then as we append here, our res, and we can append our level as well. We can kind of append it like a some level. Can we just print out res really quick? I just want to see, visualize it. If this works at all. Level plus or equal to 1. Takes 2 arguments. Takes 1 argument, 2 given. Do I need a double parenthesis here? Low key. Go. Do I have to append it as a list in a list? Would that work better? Is it tuple? So here we got 1, right? The levels are wrong. This needs to be 0. Alright, so we got level 1. Our max is 1. 7. Well, the maximum is 7 of this level, but this is level 2. And then we got 3. Okay. We're going to have to use some sort of like lambda function in order to calculate this or something. Calculate our max in the array. Return our second value. In the tuple. Yes, we do lambda function. We do need a lambda function. Returning sick value that tuple. Which of them when does the number of tuples in the array? Okay, cool. Now here we need to find our max and return second val in tuple. Tuple slash list. I don't know what to call it, to be honest. Is it a tuple? I guess it is both. I don't know. Let's take a look. Lambda function, Python. See if we can do it this time. Lambda arguments expression. Add is equal to lambda xy, x plus y. Okay. Do we do max val is equal to lambda x0. We do the max of x. Does that work? I don't know. Okay, maybe not. They got here the max val. We do the max. And then we have our lambda function in here. So we have our res. We have lambda. Oh, we use a key. Okay. Key is equal to the lambda of x, x0. So we're doing, I think what this means is the key is the x, and then we're looking at x0, and we're getting the max of that, I think. Let's print out max val. Perhaps you forgot a comma. Valid syntax. Perhaps? Did I forget a comma? Lambda. Then we want to just return our max val and 1 in our tuple. In our little list. There we go. Was there a better way to solve that? Probably. Let's take a look. Better than editorial 2. This guy did. What the hell is this? Sum of the current level. Optimized and 100% faster. Uses 2 less current level nodes and next level nodes instead of a queue. Efficiently tracks level wise nodes without extra dictionary lookups. Uses sum. Simple and efficient. This is what I did. He did a lambda too. Is this a lambda? I don't know. He uses a dictionary though. Okay. All right, that's enough with trees today, I think. I mean, we're going to hit 40 problems there, so pretty happy about that. Woo, 40 problems. Let's go. Let's do some more Leetcode 75 here. Been going for about an hour, so dude, what is this, dude? Solved 3 problems. Let's go. We got 40 views on the profile, dude. Go, dude. Go, Ted. Go, Ted. Okay. Let's continue here with that maximum average subarray. Let's just slam through these problems, hopefully. When did I solve this? Must have been a long time ago. December 12th. You're given an integer array nums consisting of n elements and an integer k. Find a contiguous subarray whose length is equal to k that has a maximum average value and return its value. And whose length is equal to k. Okay. K is equal to 4. We're trying to find the maximum. A contiguous subarray whose length is equal to k that has a maximum average value and return this value. Any answer with this calculation error less than 10 to the negative 5 be accepted. Who wrote this test? Get a job, bro. ChatGPT. Okay. Let's take a look. We return a float. Interesting. Okay. So obviously we're going to need a left pointer. We're going to iterate through for right in range length nums. Okay. From here, we need to check, well, we need to check the size of our window. So if k, which is our size of our window, okay, so we do if right minus left, it's left plus 1 is equal to k. Checking if we hit window, right? If we hit our window, then we can calculate our max average. So we can do that. We can slice the array and we can do, well, we want to check the, let's create like a res here. Res max is equal to 0. We want to check, well, max average of slice. So we need to calculate it. So it would be array is equal to, we'd want to slice from the left to the right. I think that's how you'd slice it. I think. Can we print array and see that? I don't know. Is array equal to left, right? Is this how you would slice to get an array between left and right pointer? Okay, left, right, plus 1. That's what I meant. I was close though. Valid syntax, bro. What is going on? Oh, shit. Only way left to go. Gotta go whole heart this time. Gotta go whole heart. Damn, bro. Okay. Left, right, plus 1. Okay, we'll leave it at that, right? So we get our array. Okay. And then we do, well... Is there an average function? Do we have to do a double for loop? I don't know if I want to do a double for loop since it's going to be an n-squared approach. Is there a way that we can... Get the average of the elements in a sliced array, you can use the following approach. That is smart. I didn't think about that. Average is equal to the sum of the array over the length of the array. Then we can check our max. So this might be too slow. I don't know if this solution will accept, but we'll see. We create we need to do res max is equal to the max of res max and the average. Okay. And then we do left plus or equal to 1. Increment our left pointer. And then we go to the next right. Let's go here and then we just return our res max. Will this pass though? Is it too slow? Probably. No, it's too slow, dude. No. Is it too slow? K is equal to 1. Output is 0. Expected -1. How? -1, 1. If the length of nums is less than k, then we can just return sum of the array minus the length of the array. Will this work? I don't know. Nope. Oh. Incorrect edge case handling. You were trying to return. Oh my gosh, dude. That's so stupid. Oh, that's right. It could be negative. I didn't think about that. Okay. So we need to put this to the float. Negative infinity, right? How do you do negative infinity, dude? Oh, you just do negative like this. Okay. I think the solution's too slow. Yeah, it is too slow. Yeah. How can we make this a little bit faster? Let's doing these redundant calculations here. Like, Okay. Why is my solution is way too slow? I don't know exactly what the thing is, but it's like O of NK plus K. No, I don't know. Like, what is the solution here? O of N times K. Yeah. N being the array, and then K being I don't know, maybe the size of the window. Okay, so we have to get rid of all this, right? Through from bro, what is going on here? Loop through from K to the size of I'm gonna go from K to N minus 1. No, from the length nums minus 1. Okay. Create our current window. Our current window has the sum of K elements, right? The sum of all K through to, sorry, going up to K elements, I think. Yeah. Nums to K elements. But this needs to be a square bracket. Okay, and then we use the res element. We do for right and range K. Just to be the float of negative infinity. Negative inf. Then we want to do, well, code window plus or equal to we want nums right minus I guess we could do like a left value too. Code window plus equal to nums right minus nums left. Code window plus equal to nums right minus nums left. I guess our res can be the max of Res max code window. Ah, okay, they do the divide by k last. Interesting. Sorry, res. Whoops. Whoops. Oh shit. I'm not incrementing our left pointer. Left plus 1, left plus equal 1. There we go. Nice, dude. Nice. Cool. We did that one. I'm definitely excited for this heat priority QR because I really need to start loading this. Like, this is cool, man. I like playing with this. Okay. Yeah, let's keep pushing. Let's do prefix sum. Not the best with prefix sum. I definitely think this would be a good one for me. There's a biker going on a road trip. The road trip consists of n+1 points at different altitudes. The biker starts his trip on point 0 with the altitude equal 0. You're given an integer array gang of length n, where gang I is a net gang in altitude between points I. Kind of road trip. The road trip consists of n+1 points at different altitudes. Okay. The biker starts his trip on point 0 with an altitude equal to 0. Okay. You're given an integer array gang of length n, where gang I is a net gang in altitude between points I and I+1 for all I and n. Return the highest altitude of a point. Okay. So if you're looking at this, the highest altitude would be 5 here, right? Because you return the max value, but that's not what we're doing. We start at 0 and we go down. The highest is 1. I think we're returning like 1 here, you know, and then we're returning the 0 here, the index. Doing the prefix sum of the array. Prefix sum. Prefix sum is a technique used to pre-process an array so that we can quickly calculate the sum of any subarray in O of 1 time after an O of n pre-processing. Okay. Probably gotta finish up here soon. We have been nearly gone for 2 hours. I'm gonna try and finish this problem. Maybe if we have time, we'll do the next one. But okay, let's create our res array, right? And then we want to loop through. Well, for I in range length of gang. When did we do this problem too? This has been a long time ago because I don't remember this. September 19th, 24. Okay. Range length gang, right? And we do well. We have our res array. And then okay, res let's just print out res here. It's gonna get pissed at me if I return an array. It's not gonna work. Can I actually? Sum is equal to 0. We start at 0. Shit. Gain I. Okay, -5, -4, 1, 1, 6. Wait. Where's these? Oh my gosh, dude. Oh. So really, this isn't correct, right? So we need to actually, this should be 6, I think. Right, so we need to do, well, is equal to right. Would it be the, will we use the absolute, right minus left? Sorry, yeah, we don't have right minus left. Nums I. See, I think this is a good problem for me because I struggle with prefix sum and the way that it works. So gain I. I'll also compute the cumulative sum. Man, was I originally right at first? Plus A equal to gang. How do we start from -5 and go to 1, but then we go -4? Oh. Okay, we start at -5. Wouldn't that be a positive altitude change? See, I'm thinking it should be 6, 4, -5, -7. Max alt prefix sum. Prefix sum. Let's print it, and then we just return. How? Is this how you do it in Python? I'm not too sure. Alright, whatever. I copy stuff to figure it out. But how is that the altitude? Zero. Start at 0. We go to -5. Either this question is worded so bad, or it's how. Gain of 6. Is equal to 1. I think this question is just worded like incredibly badly, like, because I'm getting confused by the question. Like, this was an easy problem, but I'm just like confusing description. Should be tagged out. I cannot understand this problem. Yeah, this was a terrible description. Like, bro, insane. Like, it was just so confusing, bro. Like, okay. All right, I know we've been going for about, what, 2 hours now? Nearly 2 hours. Let's finish this last prefix sum and we'll call it. I want a better problem, to be honest. Given an array of integer nums, calculate the pivot index of this array. Pivot index is the index where the sum of all the numbers strictly to the left of the index is equal to the sum of all the numbers strictly to the index's right. The index on the left edge of the array, then the left sum is, if the index is on, if the index, oh my gosh, dude. Okay, if the index is on the left edge of the array, then the left sum is 0 because there are no elements to the left. This also applies to the right edge of the array. Return the leftmost pivot index. If no such index exists, return 1. Return the leftmost pivot index. Okay. We got 9, 8 here. What? Oh, we're returning the index. Okay, 0, 1, 2, 3, 6. We got 3, 10, 11, and then 11 here. This question is the same as 1991. What is this one? Okay. Okay, let's loop through our nums array. For I in range length nums, we want to check well. First, we probably want to check if it's a yeah, we want to check if it's a what do they call it here? An edge on the left edge or right edge. So how would we check if it's left edge or right edge? Well, we do okay, if I is equal to 0, then trying to think here. Okay. Well, let's take our left sum is equal to 0. And our right sum is equal to 0. If I is equal to 0, our left sum is equal to 0, and our right sum is equal to a max of nums we want to slice from the okay. So I probably shouldn't do the edge cases first. Let's just pretend that we've been through. So we do, well, our left sum is equal to, we want to go nums, we'd want to go up to I. So I think it would be like this. And our right sum would be equal to nums, and then we go from I don't think we'd want to include them, so we need to do I minus 1. Okay, and then we check, well, if left sum, if, oh, we need a max around this. We check, well, if left sum is equal to right sum, then we found our value. Then we just return I, right? Otherwise, if we don't find anything, we want to return -1. Okay. Other than this, we want to check left, check right. We want to, how do we do this? We need to check the bounds here. When did we do this problem? 23rd. We need to check the bounds. So if left sum do if I is equal to 0, if sum is equal to 0, right sum is equal to the length of, sorry, max then we need to do our own if statement in here too. Else we break. All right. I don't think this is the way to do it. The length of nums minus 1. Then we do the opposite. Our left sum is this, and our right sum is 0. We return I, otherwise we break. Shit, it actually ran. I'm not sure what my issue is here. Oh shit, we want the sum. Yeah, bro, I'm doing the max. My gosh, bruh. Sum. Yeah, I'm not even doing the prefix sum approach. Total sum is equal to the sum of nums. We loop through. Yeah, that's a better way to do it. Right sum is equal to total sum minus left then minus the number that we're looking at, nums I. Okay. If left sum equal to right sum, we return I. Otherwise, we want to left sum plus or equal to nums I. That's the way to do it. Interesting. It's good to look at that problem again. Maybe we'll take a look at them again in a couple days. Nice. All right, we're going to call it there. I appreciate you guys watching, and I'll see you tomorrow.